verify the identity. Cotangent squared t over cosecant t is equal to cosecant t minus sine t. Well, our first job when we're verifying identities is to choose one of the sides to start on. And we commonly think of it as picking the harder side, the more complicated side. I prefer thinking of it as picking the side on which I see something to do. And so I have a fraction, I have subtraction. There's no real easy way to tell which one of these is more complicated, but I'm going to pick the right-hand side to start. And just as a little spoiler, I'm actually going to do this one two different ways. I'm going to do this one again in a moment, choosing the left-hand side first. All right, so here I have cosecant t minus sine t. And the first thing I see to do here is use a reciprocal identity. Cosecant is the same as 1 over sine. Next up, since now I'm subtracting something involving a fraction, I'm going to find a common denominator. I'm thinking about multiplying the second part here, sine t, by sine over sine to make it have a denominator of sine. So let's see, I found a common denominator. I can write this as one fraction. And so let's see, what did I do here? I've really just subtracted. I have 1 minus sine squared t. A Pythagorean identity tells me that's the same thing as cosine squared t over sine t. And maybe in this moment you see exactly what to do next. You know exactly how to turn this into that. But I just want to pretend for a moment that I don't, and that I'm stuck, and I don't know what else to do. I've picked a side, I've worked on it, I've gotten stuck. And that's okay. Because what I'm going to do now is say, well, if I'm stuck, maybe I pick the left-hand side and I do some stuff on it. And I don't know, the thing I would most naturally think to do to this side, I think, is rewrite everything in terms of sine and cosine. And so I have cosine squared over sine squared divided by 1 over sine. And let's see, on the top, I've used a quotient identity. On the bottom, I've used a reciprocal identity. And what I can do now is rewrite this as a multiplication problem, thinking about how we divide two fractions. And I have a sine squared on the bottom and a sine on the top, so I end up with just one sine. And it's like I'm stuck again, but I realize that I'm stuck in the same place. So let's see, what did I do here? I've actually done the division and then I simplified it. But if I just imagine, hey, the right-hand side's equal to this, the left-hand side is equal to that same thing, so they have to be equal to each other. I can actually imagine tracing this through and then working backwards to get to there. I've verified this identity. And some people out there watching this might be thinking, hey, you worked on both sides. And I'm going to say that's okay, because I worked on both sides independently. Our rule wasn't just to work on one side, it was to work on one side at a time. I'm allowed to work on both sides of this independently of each other. I'm not allowed to look at my identity and say multiply both sides by the same thing to start, because that would change the domain of my identity. In a trigonometric identity, an identity in mathematics is a statement that's true for all of the values of the variable in the domain of both sides. So we don't want to go around changing domains. All right, we've verified this identity, but I promised you I was going to do this one two different ways. This first way involved working with the right-hand side and then the left-hand side independently of each other. There's a way of doing this one where you just start on the left-hand side and you just make a different choice of what to do first. Every trigonometric identity you ever meet has more than one way to be verified. What I want to use here on top is a Pythagorean identity. And the reason I might think to do that is because the right-hand side is a difference. And cotangent squared t happens to be equal to cosecant squared t minus 1. Leave the bottom alone. So I've used a Pythagorean identity. Well, now if I just do the division, where I divide everything by cosecant of t, I'll be done. So let's see, I've done the division. One of the cosecants cancels, and 1 over cosecant is sine. which is a reciprocal identity. And then we've arrived at the right-hand side. So now I have two different methods of verifying this. This one's more complicated. I'll admit this is probably what I would think to do more often, but there's a nice simple approach to verifying that identity.